So here we are, continuing our discussion of oxidation numbers and redox reactions. We're going to do a practice problem. So, determine the oxidation number, which, remember, is the imaginary charge of sulfur, so we're only going to focus on sulfur, in these 5 compounds. So let's look at hydrogen sulfide first, H2S. Now, according to our rules, when hydrogen is bonded to a nonmetal, it's usually +1. So I'm going to write +1 above the hydrogen. Now, I have 2 hydrogens. So if each hydrogen is +1, 2 times +1 is a total of +2. The whole compound, it's a compound, so the total charge has to equal 0. So if the total charge on the hydrogen is +2, this is meant to be an arrow, then the oxidation number on the sulfide has to be -2. So that would be, in this one, the oxidation number on the sulfur would be -2. Let's do the next one, S8. Okay, S8 is sulfur in its elemental form. There's nothing else combined with this sulfur. It's not an ion, there's no charge. So any element in its elemental form is going to have an oxidation number of 0. So therefore the oxidation number on sulfur in that one would be 0. So you can see they can be different. They can have different numbers of electrons assigned to them, sort of in this imaginary charge thing, depending on how they're structured or who they're bonded with. The next one, C, we have sulfur chloride. So in this case, we said in one of our rules that the oxidation number of chlorine, of the halogens, is usually -1, unless we have a reason to make it not -1. So we're going to make it -1 here. Now we have 2 chlorines. So if each chlorine has an oxidation number of -1, that's a total oxidation charge on both chlorines together of -2. And the total charge on this compound has to equal 0 because it's a compound, it's not an ion. So if the total charge on all the chlorines is -2, I usually write my total charge down here and my individual one up here. The total one is -2, then the charge on this sulfur, since there's only one of it, has to be -2. So the charge there would be -2. The hypothetical charge on this sulfur, the way we're assigning electrons in this compound, because it would be a sulfur bonded to a chlorine and another chlorine, and we're assigning 2 extra electrons to the sulfur to give it a, wait a minute, see, made a mistake. This has to be +2. This has to be +2 because +2 plus -2 gives you 0. If it was -2, you'd have a charge of -4, which is impossible. I hope you caught that. This has to be +2. Next one, we have D is sodium sulfate. Actually, that's sodium sulfite, SO3. Sodium sulfite. So in this case, oxygen is going to be -2 because it usually is. This is not a peroxide. So if the charge on each oxygen is -2 and we have 3 oxygens, then the total charge on all 3 oxygens taken together will be -6. Did I go over? I don't think I mentioned in the rules, but the group 1 metals and the group 1 metals tend to have a charge, well, they're ions, so they would have a charge of +1. So the sodium's going to be +1. So +1 plus -6 gives you +5. Clearly my math is. So the sulfur has to have an oxidation number of +5 because +1, oops, go away, stop, +1 plus +5 is +6, and +6 plus -6 gives you 0. And finally, the last example, E, right here, is the sulfate ion, SO4 -2. So that means the whole ion, I should make this clean this up. So I'm rewriting this down here, SO4 -2. That means this is an ion with 1 sulfur and 4 oxygens that are covalently bonded. It's a sulfur with 4 oxygens bonded to it, and as they drift around in space, this whole thing has a charge of -2. It has 2 extra electrons distributed among that whole thing. So let's figure out the oxidation number on the sulfur in this polyatomic ion. Well, the oxidation number on oxygen is usually -2. So if it's usually minus 2 and we have 4 oxygens, count them, 1, 2, 3, 4, and each one has a charge of minus 2, or a oxidation number of minus 2, 4 times minus 2 is a total of minus 8 for all 4 of these oxygens. Leaving, that means that the sulfur's oxidation number has to be plus 8, because plus 8 plus minus 8 equals 0. So for this one, the charge on the sulfur has to be plus 8. So you can see how they differ.